Okay, this video is going to be some review and some examples of both work and power, and then also something about mechanical advantage. So we did this in class, but it's good to go over it again. Feel free to skip forward if you want to. So as far as work and power goes, our two equations we work with are work equals force times distance, which we could abbreviate as W equals F times D. Suppose if you wanted to, it could be W equals F times X for distance, but D is okay for distance. Remembering that in this particular situation, this W is a variable that stands for work. Later on, we're going to have a W as a variable that stands for watts, so you got to pay attention to those things. In general, when you're doing work, then you're transferring energy to or from an object via force. And then we also brought in power into the fold here by saying work divided by time. Oh, sorry, the units for work up here are going to be joules, and down here our units are watts for power. So power is the rate at which work is done. And in class, when we did our 1 horsepower challenge, that's what we were figuring out. So those are our two equations. This one can be abbreviated power equals work divided by time, like that, if we wanted to do it that way. So let's just jump into these examples, and then I'll solve them on a separate piece of paper down here. So this one says, find the power necessary to lift a 20 kilogram box of cookies up to a height of 3 meters in a time of 5 seconds. So of course, if we're looking for power, we would potentially write down this formula, power equals work divided by time. That's great. And in true physics fashion, you have to do one thing before you do the other. So in order to find the work is going to be force times distance. And thinking about what this force is going to be, the force is going to be the force of gravity to lift up that object. So that's going to be mass times g. Right? So in this one, if I have a 20 kilogram box and I want to lift it up, how much force do I need to lift that up? Well, that's going to be 20 kilograms times 10 for our gravity. 10 meters per second squared. So that's going to give us 200 newtons. That's the force necessary to lift it up. So now we can take this and put that back into our work equation over here. So the work is force times distance. That's 200 newtons times our distance is 3 meters over here. So that's going to be 600 joules. Good. And now I can take this 600 joules and put it back into our power equation over here. Power equals work divided by time. So we get 600 joules divided by 5 seconds. And that's going to give me 30 watts. And I'll write it down here as watts. Good. Now, if you're clever, you could see how you can maybe kind of one-stop shop this and do this all in one step by combining these two equations together. Just writing power is force times distance divided by time. And then sticking in the numbers that we had here, 200 times 3 divided by 5. So it could have worked that way as well. Okay, so that's one example. Another example over here. Let's flip this over. A motor has a power output of 20 horsepower. How much weight can it lift to a height of 10 meters in a time of 1 minute? So just recalling, and that 1 horsepower is 746 watts. Actually, I need to grab my calculator. So the first thing we're going to need to do is we're going to need to change the 20 horsepower into watts. So we'll clear this out, and we have 20 horsepower times 746, and that's a lot of watts. So our power here is going to be 14,920 watts. Good. So the motor has an output power of 20 horsepower. How much weight can it lift to a height of 10 meters in a time of 1 minute? So it might be nice to just start with our general equation for power. Power is work divided by time. work is force times distance. In this case, I think it's easier to combine these and say power is force times distance divided by time. And now what we're doing is we're trying to figure out what of these do we know and what are we trying to figure out. So we know the power, we know the time, that's 1 minute, we know the distance, that's 10 meters, and what we're trying to figure out is the force, how much weight can it lift? So that's the number in newtons of weight that this thing can lift. So one way to do this might be to stick in all the numbers and then solve for the distance here, solve for the force. But I think it's actually more instructive to just use some algebra and change this into a formula that has force. And what I'd like to encourage you all to be able to do is just to kind of one-stop shop algebra in your head. And if you need to take a couple steps to do this, that's fine. But I can rearrange this and say force is power times time divided by distance. Right? So the time goes over and then the distance goes over. Now I can just stick in all the numbers that I have right here. So I have, my power is 14,920 watts. My time is 1 minute, but that needs to be in seconds, 60 seconds. And my distance is 10 meters over here. Good. So I still have this number in here. I'm going to multiply that times 60 divided by 10 is really just times 6. So how much weight I can lift with this motor in that amount of time is 89,520 newtons, which is a lot of newtons, but it's also a pretty powerful motor here, 20 horsepower, and it's doing a whole minute of time for that. So you might think, well, that's really quite a lot of newtons to lift up, but it is a powerful motor. Okay, let's do one more example here. Just flip this over. So now it says, Bob the physics student claims he can output 1.5 horsepower with his body. How much time will it take him to lift a 70 kilogram barbell up to a height of 2 meters? So once again, we're going to start with power is work over time. Work equals force times distance. Combine those together into power equals force times distance divided by time. All right? And what are we looking for here? Well, we're looking for how much time it will take. Oops. So we're looking for how much time it will take. So let's rearrange this formula into time equals. Now, algebra-wise, you can always switch the numerator and denominator on opposite sides of the equal sign, right? So I can just bring the t over and bring the p over. So t is force times distance divided by power. And one thing I need to do is figure out the force. So if I have 70 kilograms times my 10 meters per second squared, that's going to give me 700 newtons. That's the force that's necessary to lift that up. So then we're just going to plug things in over here. I have 700 newtons as my force. I've got 2 meters as my distance. My power is, 1.5 horsepower. We got to figure that out. 1.5 horsepower into watts. 746 watts times 1.5 horsepower, 1119 watts, 1119 watts. So that goes down here. And now I just do my math here. Well, 700 times 2 is 1400 divided by 1119, and I get a time of 1.25 seconds. Good. And just looking back at the problem, yeah, okay, an output power of 1.5 horsepower is quite a lot for a person, but if they did have that much power, they could lift a pretty heavy weight up above their head in 1 second. So that seems reasonable. Okay, let's go now and refresh our memory on mechanical advantage. So mechanical advantage over here we talked about in class is something to do with a simple machine. Let's see if I can get this to focus a little bit better. There we go, that's a little bit better. So when we have a simple machine, what we're trying to do is we're trying to move something and we're changing the distance that the force is applied. And it's going to change the amount of force necessary to do that. So our simple thing right here, the most basic one was kind of our lever, right? And if I, let's see, you got to get this whole thing in view here. So if I push on this side of my lever, okay, got to go this way. I don't know how I can get it into view. Okay, good. So if I push on this side of my lever, then this is probably the wrong way to do it on the lever. So let's put the fulcrum over there. There we go, that's going to be a little bit better. Let's put something really heavy on this side, like that car. So now I can push on this side of the lever here, and I can lift up that car, but my input distance is way bigger than my output distance, right? So my input distance on this side is quite a lot more than my output distance on that side, which means that my input force on this side is less than my output force on that side, right? And that's what's going to give me a mechanical advantage. It's going to be this ratio of my input distance over my output distance. So just looking from a side view over here, when you have a lever, how much force you're inputting on this side of the lever, and here's the force you're outputting on this side of the lever. So you can use a small input force to get a large output force. But the payback is distance. I have to have a big input distance and a small output distance, right? But the other side of the notes over here say the input work has to equal the output work, because work is a type of energy. So I can't have more input work than I have output work unless I've got some sort of other source of energy. So we get this equation here. This is our Find-in/Fout-Dot equation. So force in times distance in equals force out times distance out. This one right here we talked about in class. A simple machine makes the input distance big and the output distance small. So if you have a big input distance and a small output distance, you can have a small input force and a big output force. All right, now moving on to our equation for mechanical advantage, and then we'll do some examples. Mechanical advantage means how much easier is it to do something because you have this simple machine. There's two ways we can figure it out. Either you can take the ratios of the distances, or you can take the ratios of the forces. For the ratios of the distances, I want my distance in divided by my distance out. And that's going to give me my mechanical advantage. Or I can take my force in divided by my force out. Now, of course, these both equal mechanical advantage, so you could say this equals this. So I could write distance in over distance out equals, oops, oh no, this is totally wrong. Uh-oh. I'm so sorry, you guys. This is wrong over here. This should be force out over force in on this side, because my output force is going to be bigger than my input force. So sorry about that. This is going to be force out over force in, like that. So this is actually, if you cross multiply, this is just our same equation back up here again. But what mechanical advantage means, and I just want to make sure you kind of are getting the gist of it here, with, aside from the equations and all the numbers and stuff, what it really means is how much easier is it to do something. So, oh, there goes my lights in the classroom. Hold on. Okay, so if I'm trying to lift this car up over here, let's say this car is 1,000 pounds. I can't lift 1,000 pounds by myself, but I can set up a lever system where I can lift it up. And the mechanical advantage is going to be how much easier is it to lift that. So let's say I have a mechanical advantage of 5. So in order to lift up this 1,000 pound car, I only need to lift with 200 pounds on this side, because that's 1,000 pounds divided by 5, right? So that is my output force here is 1,000 pounds, and my input force is, 200 pounds, and when I divide those, I get 5. That's my mechanical advantage. So I can input 200 pounds and I can lift up 1,000 pounds. But the payback is in the distance. So if I wanted to lift this thing up 1 foot, then I'd have to push down with 5 feet over here. Now I recognize I went back into regular units of pounds and feet and things like that, and usually in physics we're using newtons and meters, but it doesn't really matter since it's just a ratio. So I'm trying to lift this thing up 1 foot, and I have to input 5 feet on this side. So my input distance was 5 feet, and my output distance was 1 foot, and I still get a mechanical advantage of 5. If I do this Find-in/Fout-Dot equation over here, my force in was 200, and my distance in was 5. And that has to equal my force out, which was 1,000, and my distance out was 1. And it checks out. There we go. Sorry, I wrote it down here. Force in was 200. Distance in was 5. Force out was 1,000. Distance out was 1. And those two things equal each other. So let's just do a couple quick examples over here. Okay, we'll talk about efficiency in just a minute. Okay, so hang on to that efficiency thing. So here's a quick example. It says, a lever is used to lift a 200 kilogram block of wood. When one side of the lever is pushed down 40 centimeters, the other side is lifted by 10 centimeters. And question A says, find the mechanical advantage of the lever. So this is easy. Mechanical advantage is just going to be my input distance divided by my output distance. My input distance is 40. My output distance is 10. 40 centimeters divided by 10 centimeters, and that's a mechanical advantage of 4. Notice how there's no units over here. There's no units because it's centimeters divided by centimeters. It's really just telling you a ratio. Find the input force necessary to lift the block. So I can go here, still mechanical advantage is going to be my output force divided by my input force. It still has to equal 4 though, because I have it's the same lever system over here. So what do I know about this? I'm looking for my input force, and what's my output force? My output force has to be how much force it takes to lift up that 200 kilogram block of wood. Well, 200 kilogram block of wood times 10 for gravity is going to have a weight of 2,000 newtons. So if I'm putting in the equation over here, if you're an equations person, I'm going to get 4, that's my mechanical advantage, is, 2,000 newtons divided by whatever my input force is. So my input force is going to be 2,000 newtons divided by 4. That's going to be 500 newtons. And what it means, mechanical advantage means, is that if I'm using this lever to lift this block of wood, it's going to be 4 times easier. So 4 times easier than 2,000 is 500, right? I divided it by 4. But I have 4 times as much distance on the input side, 40 centimeters versus 10 centimeters. Okay, let's do one more example, and then this will just bring up the efficiency thing, and I'll show you it's actually pretty easy to figure out the efficiency. Okay, pulley system has a mechanical advantage of 6. How much input force does it require to lift a 300 kilogram car with the pulley system? So once again, I got to change things into forces here. 300 kilograms times 10 for my gravity, that's 3,000 newtons. That is how much output force I need because I'm trying to lift up this car engine. That's how much it's going to require. So my input force, without even doing an equation, is going to be 6 times less than that, right? I have to put in 1/6 as much input force as the output force. That's what it means to have a mechanical advantage of 6. So I can just divide this by 6, and that's going to give me 500 again, same as the last problem. But if you like to do an equation, then we'll do mechanical advantage is force out over force in. My mechanical advantage is 6. My force out is 3,000 newtons, and I'm just trying to find my force in, and I'll get 500 newtons out of that. Okay, now let's look at this one. Let's say this system has an efficiency of 0.8. Now calculate the input force necessary to lift the engine. So as far as efficiency goes, what we say is that sometimes the work input into a machine won't equal the work output due to friction. So you're going to end up having to put a little bit more work in than you're going to get out. It's usually a number between 0 and 1. A lower efficiency means more energy lost in your machine. So going back to this problem, let me just show you how easy this is. I have an efficiency of 0.8. That efficiency of 0.8 is going to affect my input force. So I had an input force of 500 newtons when the pulley system had 100% efficiency. But now we're looking, let's say it has an efficiency of 80%. It's only 80% efficient. Well, what I need to do is I need to use this factor of 0.8, and I need to increase my input force somehow. So I'm going to take this 0.8, and I'm going to multiply or divide or do something to this in order to make this number bigger. It's not an add or subtract thing. This is a multiply or divide. So how can I take 500 and 0.8 and multiply or divide them to get something bigger than 500? Why bigger than 500? Because friction is going to make it so I actually need more than 500 newtons to lift up this whatever it was, car engine, right? So with 100% efficiency, it's going to take 500 newtons, which with less than that, it's going to take more input force because it's going to be harder to lift up because I've got some friction in the way. So the way that I can actually make this number bigger is if I take 500 newtons and divide it by 0.8. That's going to make this number a bigger number, right? So when I take my 500 newtons and I divide it by 0.8, then I'm getting 625 newtons. So with 100% efficiency, it only takes 500 newtons to lift up the car engine. But with this 80% efficiency, it takes more than that, more force, because I'm losing some due to friction over here. So that's how it's going to go. 500 divided by the efficiency. So I'm taking my input force that I would have gotten with 100% efficiency, dividing it by my 80% efficiency, and I'm getting this new input force over here. Okay, hopefully this was helpful for you all, and we will talk about it more in class.